So welcome back for yet another video of K-maps. Well, about K-maps actually, but anyway, of, things about the K-maps. So once again, let's suppose that we have our Karnaugh map. And we count with gray code. 0, 0, 0, 1, 1, 1, and 1, 0. Then we have 0, 0, 0, 1, 1, 1, 1, 0. And again, 0, 0, 0, 1, 1, 1, 1, 0. And let me just make the map here, so the structure in green of this map, like this. There we go, like this. There we go. And here at the bottom we have E, which is our last input. We have A, B, C, D, and E. So let me get the structure right. Hopefully it's not gonna be too bad. Yeah, not particularly precise when I draw things, nor when I make tables with my bare hands. And of course you always have computers to do that, especially doing computations, but here I'm with pen and paper, so I'm gonna stick with it. Okay, right, so the structure is fine. Okay, so let's suppose that we have 1, 0, 0, 0, 1, 0, 1, 0, and then we have 0, 0, 1, 0, 1, 0, 0, 0, and we have 1, 0, 0, 0, 1, 0, 1, 0, 0, 0, 0, 0, and then 1, 0, 0, 1. With these as a 0 and these as 1. So our inputs, our entries are A, B, A, B, C, D, and those are E. Now, once again, we're going to use the mean terms. So we're going to be interested in finding the prime implicants with the 1 and making groups with the 1s. So how do we do that? Well, those two are like two layers, one at the bottom, this one at the bottom, and this one at the top, so they can communicate one with the other. Therefore, I can start with a group of 4 with those two and those two. So I'm gonna have a group of 4, like so. Then I cannot have, well, I can have a group of 2 here, and then a group of 2 here. With those two, one at the top and one at the bottom. And then I can have a group of 2 here with this one and this one. So these are the bottom, and this one at the top, and a group of 2 between those two at the top. So again, with the analogy of the cube, of the surface, Am I getting better in drawing cubes? No, I am not. I am not. I'm so bad at drawing those things. Yeah. Okay. So, right. So this map is actually flipped like this, and it's at the very bottom. So if we look at this map like this, we can actually say, okay, so those two are here. So we have those two. And we have the same two at the top, like so. So we have a whole group of 4 here, like this. Now, if we move on, we have a group of 2 here. So again, this one is like this. So we have a group of 2. Those 2 are like here, 1 and 2. So this one is a group of 2. And we also have a group of 2 between this one at the top and this one at, I'm sorry, this one at the bottom and this one at the top. So actually between those 2, like so. And we also have a group of 2 here with this one and this one. So this one at the bottom and this one at the top. And we also have a group of 2 between those 2 at the top. Like this. Right. So now, since we're using the Minter representation, we're utterly interested in the applying the implicants with the 1. So we're interested in where A, B, C, and D, and E are asserted, which basically means where they are 1. So A, once again, is 1 here, and here. B is 1 in the middle, so here, and here. C is 1 here, and D is 1 in the middle. Lastly, E is 1 only here on this plane, on this top plane. Now, those are actually going to give us our function. So why don't we start with this group of 4? Now this group of 4, it's completely outside of A, so we're going to start with A naught times, it's completely outside of B, so we're going to have B naught times, it's completely outside of C, so we're going to have C naught, it's half inside and half outside of D, so we're going to leave D alone. And of course, it's half inside and half outside of E because it's basically taking into account those 2 planes. So it's half and in the bottom and half in the top plane, while E is asserted only in the top plane. So we're going to leave E alone as well. Then we're going to move to those 2. Now, those 2, this group of 2 is actually inside A, so we're going to have A times. It's actually inside of B, so we're going to have times B. It's half inside and half outside of C, so we're going to leave C alone. And it's completely inside of D, so we're going to have D. It's also completely outside of E because it's all in the bottom plane, so we're going to have E naught. We're gonna move to this group of 2. So between the bottom plane and the top plane, it's completely inside of A, so we're gonna have A times. It's completely inside of B, so we're gonna have B. It's completely outside of C, so we're gonna have C naught or C complement. and it's completely inside of D, so we're going to have times D. Lastly, we're going to leave E alone because it's half inside and half outside of E, as it's basically both in the bottom plane and the top plane. Now we're going to move to the last but one group, which is the group between this bottom plane and this top plane. So this group of two. It's actually completely outside of A, so we're going to have A naught times. It's completely outside of B, so we're going to have B naught. It's completely inside of C, so we're going to have C. And it's completely outside of D, so we're going to have D naught. Again, I'm not gonna write anything for E because it's actually using those two planes, and E is only asserted, so only positive wind at the very top plane. So I'm not gonna write anything for E. And now I'm gonna have the very last group between this one and this other one, so a group of two in this very top plane. So this group of two, it's half inside and half outside of A, so I'm not going to write anything for A. It's completely outside of B, so I'm going to have B naught. And it's completely inside of C, so we're going to have C. It's completely outside of D, so we're going to have D naught. And it's completely inside of E because it's all in the top plane, so we're going to have times E. And this is actually our function for these particular Karnaugh maps. Karnaugh map. So yeah, once again, you can actually use the Karnaugh map to get a function out of your map. Again, you can basically write a Karnaugh map if you have a truth table or other kind of representation, and you can basically use the either the min term or the max term, depending on whether you have more 0 or more 1. It's the same, just that it's easier if you have less ones to use min terms. Otherwise, use max terms. So yeah, and whenever you have all those entries, remember that you are basically in two planes, one at the very bottom and one at the very top, and they are connected between one another. So stay tuned. This is basically it for this video, but stay tuned because I'm going to have one last video about Karnaugh maps and their representation. And I'm basically I'm not gonna have an example as a very last video. I'm basically gonna say, well, you can do this and you can't do that, and vice versa. So some of the best practices, and well, they're not tricks, they're rules, but I'm gonna talk about them a little bit. So yeah, stay tuned and bye for now. Cheers.